All right, so where did we leave off, class? We were doing R2, and we had just got done doing order of operations. Chair feels funny. There we go. We didn't touch number lines or absolute values yet, so that's where I'm going to start up here. This is going to be the rest of R2. 35. This is R2 part B. So we need to talk about number lines before I hit absolute values. Number lines are kind of handy if you've got a line with, let's put 3 dots on there, A, B, and C. So when numbers are to the left of other letters, we say that they are less than the letters. So here A is to the left of B. A is less than B. A is also less than C because it's further to the right. And B is also less than C. This is the less than symbol. And if we want to talk about it going the other way, talk about C in relation to the others, since C is larger than, numbers are bigger going to the right. So like bigger numbers over here and smaller numbers over here. C is larger than B and it's larger than A. We will use this symbol to represent that. And that's the greater than symbol. And B is also to the right of A, which means B is larger than or greater than A. Let's see. These are collectively called the inequality symbols. Inequality symbols, less than and greater than. If we throw in this and this, they look kind of like the less than and the greater than, but they have a line underneath it, which is like half of an equal sign. This is less than or equal to. It's a twofer. And that one is greater than or equal to. So for example, 2 is less than 5. 2 is less than or equal to 5. 5 is less than or equal to 5. And normally you wouldn't bother saying 5 is less than or equal to 5. Once you already, tends to be for values you don't know. So this tends to be for like values X less than or equal to 5. And so this just says X can go up to 5. But if you were to have 5 less than or equal to 5, you would just say 5 equals 5 and you'd be done with it. Same thing with the other way. 6 is greater than 3. 6 is greater than or equal to 3. 6 is greater than or equal to 6. So 6 is greater than or equal to X. You can switch back and forth between these if you like. Like I don't particularly like having X on the right. It bothers me immensely. If you're going to move it, treat this as an alligator, and the alligator has to be going after the same goddamn thing when you're done. So if you're going to put the X on the left and the 6 on the right, the alligator better be going after the 6 when you're done. Another way of dealing with this is you have 6 is greater than or equal to X. You can multiply. This sounds funny. I'm not going to do that here. It'll come out naturally. It's just going to sound silly there. That's how number lines work. Any questions on number lines? less than or equal to, greater than or equal to. We'll be doing a bunch of stuff with it. It shows up. Not as much as the regular good old equal sign, but we will do some stuff with inequalities. The other thing in this section is absolute values. Absolute value represents the distance from 0 on a number line. Distance has a convenient trait about it. It's never negative. You have never gone -3 miles anywhere in your entire life, ever. You have never taken a negative step. You just walk the other direction. Not even walking backwards isn't even a negative step in terms of distance. So distance is always greater than 0 or equal to 0. And another way of saying it in the math world is distance is non-negative. So if you see non-negative anywhere in anything, it means positive and also 0. It's easy to go, okay, non-negative, what's the opposite of negative? Positive, but it also includes 0. So if I have a nice little number line and I got 0 here in the middle and I go to the left this way and I go to the right that way, the distance from 0 to each of these, 1, 2, this one has a distance of 2, 1 step, 2 steps, this is also a distance of 2. The way we represent absolute value is with vertical bars that tend to be bigger than like ones. So if you make one a certain size, make the absolute bars bigger, both above and below. So the absolute value of -2 is +2. And the absolute value of +2 is just +2. So it just boils down to make the shit on the inside positive after you've done all order of operations. So if I had something like 5 minus 7, the correct path is to do 5 minus 7 is -2, and that becomes +2. This is a big yes. I don't want to start with 5 minus 7 and say, okay, I'm going to make everything inside positive, say 5 plus 7. And I get 12. That's a big fat no. the upside exclamation point do anything other than just like say, look at me? Like even more than the regular exclamation point? It's like a big look at me. You guys ready for more? If you need this up longer, say something, raise your hand. So what does that, what's the math gig for absolute value? If I have the absolute value of A, this has two meanings. It equals A if A is greater than or equal to 0. And it equals negative A if A is less than 0. That may seem silly at some point, like why do I need to write it both ways? There will come a time eventually that you'll see something where you have X, the absolute value of X, and if you know X is less than 0, like there's no chance at all it's positive, then I can replace this with negative X and not have the absolute value signs anymore. It may not happen this semester, but there's a point that's why we have that. It shows that. Other than that, there's really no reason to have that negative, do that negative sign stuff. So what are the properties of absolute values? Let's go with A. I could number them. I like letters. The absolute value of I was going to use A, but I already used A. Absolute value X is greater than or equal to 0. Which we said already. Another one we've said already is the absolute value. Well, it's clear from the example we did with the -2 and +2. The absolute value of negative A is the same thing as the absolute value of A. This kind of goes along with C. The absolute value of A times B equals the absolute value of A times the absolute value of B. So using that rule, I could have said negative A is -1 times A, which equals -1 times net A in absolute values, and this is just 1, and that's just absolute value of A. That's using property C. Property D doesn't come up that often. It's called the triangle inequality. The absolute value of A plus B is less than or equal to the absolute value of A plus the absolute value of B. I should have done that one last. So I'm going to call this C1. And I'm going to make a C2 over here. We did multiplication, let's do division. If I have the absolute value of A over B, this is the same thing as the absolute value of A over the absolute value of B. Some examples. If I have the absolute value of -4 times the absolute value of 5, this is going to be the same thing as the absolute value of -4 times 5. And we can test that. We can show that that's true. Absolute value of -4 is +4, and the absolute value of 5 is +5. This left side, we have the absolute value of -20. -4 times 5 is -20. So when I take the absolute value of that, I get +20. And we know that 4 times 5 is in fact 20. I told you this represents distance. The thing we got for distance, we've got 2 points. Let's call this point P and point Q. And let's say 0 is over here, so this has got a value of like A, and this has got like a value of B. The distance from P to Q, you will sometimes see as D of P comma Q. You might also see it as PQ with a bar over it, which means the line segment of. Off the screen, thank you. Well, if I do distance, I want to have the bigger number minus the smaller number. This is B minus A. But if I don't know which order the values are in, I want to be able to do A minus B also. And the only way A minus B will work is if I make it absolute value. So we use absolute values to describe distance. Distance is the absolute value of the difference of the two values. That way, it doesn't matter which order you do it in, you're right. No matter which order you subtract in. Absolute value makes it correct. It's page 2. You guys ready for some more? Nope, people are still writing. Slow down. How you guys doing out there, Victor, Erica?
Yeah, I'm still here.
Good. Not going too fast?
Hello, very okay.
Okay. All right, let's proceed. Since we do a lot of plugging of values in or evaluating stuff, I'm going to have you evaluate or work out the value of evaluate is what they always say. We are going to have M equals 13. N equals -9. On A, I want you to do the absolute value of 3m plus 2n. Let's make B a little bit harder. Let's do absolute value of 2m minus 3 times the absolute value n over m plus n. In absolute values on there too. Give you a few minutes to work that out, and we'll do it as a group. You can discuss it amongst each other if you like working together. Is it Annika or Anika? Annika. Like Anakin. I can do that. That's not too hard. But if I compare her to Anakin, and that makes me like Obi-Wan. He's a good guy. I don't want to be a good guy. No. We'll wait. I'm Palpatine. That's better. Wait for the older version of Anakin. All right. If you watch Star Wars, how can you like ever think why would the good guys ever win? The good guys, what they do with the Force is they like push and pull shit. The bad guys do that shit too. And then they lightning bolt the shit out of people. How is this an equal battle? I mean, no, it's not. Bad guys would win that fight every single time. I'm not gonna push or pull you. I'm just gonna, electrocute the shit out of you. Right? You can't beat that. All right. Let's go through and walk through it. I'm gonna substitute in using parentheses my values for m and n. I got 13 and -9. And so we got to do the operations inside first. So PEMDAS again. Multiplication becomes 4 addition. So I got 3 times 13 is 39. Plus 2 times -9 is -18. And 39 plus -18 is the same thing as 39 minus 18. And that's just 21 inside the absolute value signs. And the absolute value signs are no longer needed. 21 is already positive, so this is 21. 21 as I write 22. All right, let's see what some madness we did on this next one. Did everyone get that? Everyone? Okay. I'm going to again copy down the problem, plugging in parentheses. And filling in values. M is 13, it shows up here and here. N is -9, it shows up here and here. So we want to take care of the operations we can inside parentheses. So I've got parentheses -3 times parentheses or absolute value. And then another parentheses right here. 2 times 13 is 26. The -9 doesn't change, it's -9, and since I haven't addressed the absolute value sign, we're just gonna leave it. 13 plus -9 is +4. And then I continue. I will dump the absolute value signs, making anything that's negative positive. I have 26 minus 3. And then the absolute value lines basically turn into parentheses signs when I make the inside positive. And the bottom's 4. So I have 3 times 9, that's 27. So 26 minus 27 over 4. And we clean that up, we get -1 over 4. You can leave the negative on top, or you can put the negative on bottom, or the negative out front. These two are standard placements for the negative sign. This one is true, but I wouldn't do it. It's easy to lose track of that negative sign. The middle one is probably the safest one. You've got the negative sign on top. There's no way of making a confusing mistake. The one on the left, if you write too fast, you might get that negative sign really close to that fraction. And if you're not paying attention, you may not notice it. You may just think it's the fraction. So you might read it as positive 1/4 on accident. So if you're gonna put it out front, make sure you like exaggerate it with a little bit of space like I did. See that little bit of space right there? You guys ready to begin the pain? This was not the pain. Pain coming. Pain is called polynomials. R3. You know what? Let me stop this and start it again so it makes 2 separate videos.